Alright, discrete structures application, group project B. What is discrete structures? Discrete structures is a study of objects that can be represented finitely or countably. It can be applied in the computer's application and representation in everyday lives. It deals with logic representation, relations, computation, induction, recursion, integers, counting, probability, and graph theory. The fundamentals and mathematical portion of coding that make up algorithms in Python but surface in almost every aspect of coding, including computer software, ran on binary strings of zeros and ones using discrete math. Examples of discrete mathematics in the real world would be network, transportation examples like Google Maps, railway planning, area codes, logistics, and delivery routes. Research and corporate applications, examples like healthcare records, cybersecurity. Examples of discrete mathematics in the real world, like counting. How many different outfits can you make from the clothes in your closet? Good example would be if you have 5 pieces of clothes, 3 of them being shirts, 2 of them being pants. What is the total combinations that can be made up of between those items that you do have? Probability, chances of winning the lottery. Is it better to pick the same numbers over and over, or is it better to switch into random numbers? The probability of you being struck by lightning, is chances of you being struck by lightning are higher than you winning the lottery. And so things like that discrete math is able to predict in the real world, or have some correlation and stuff like that we're able to use computers to compute. Recursions, how much would you pay over lifetime of mortgage and interest was compounded monthly. There's a bunch of AI tools and stuff like that out there, even some interest calculators and things like that you can find online. Graph theories, how to get home faster from your workplace. How does Google Maps process estimated times? Other places like how does FedEx do delivery routes, things like that. Why is it important? Because it is the mathematics of computer science. Discrete structures are significant. We rely on the ideas like logic, sets, algorithms, and graphs in every program, application, and digital systems that we use. Without discrete structures, we would lack trustworthy ways to store and search information, construct effective algorithms, establish secure encryption schemes, model networks such as the transit or internet, create machine learning and AI systems, and that is something that the AI systems have been developing over the years. And the better we use this discrete math, the more reliable, quicker information that is being displayed to us could be more trustworthy. And the discrete math and all that is used as a foundation for a lot of these programs, and it enables to solve problems quickly, well, reasons logically, and designs of systems that function in the real world. Because of this, discrete structures is extremely beneficial to anyone who works with technology and to address real world problems, not just computer science students. Here's a good example: Python program and application of discrete structures. Examples for sieve of, it's difficult to say that name, but a method is finding all prime numbers up into a possible number. So as the code here, it's asking now to find all prime numbers up to the number 30. And it gives us 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. There's another program of discrete structures about paths, distances, nodes being used here, and basically tree nodes, graph coding for Python. Further real-world applications, graph theories like GPS tracking, fastest path, social networking, friend recommendation, recursion and induction, file system navigation, sorting algorithms, probability like lottery predictions, and spam email filtering. Graph theory and social media being graphs, like users being nodes, and connections and friends as followers as edges. How does graph theory help? Friend recommendation algorithms analyze your graph to suggest people you may know based on mutual connections. Search algorithms, Google and Facebook use graph theories to rank content based on relevance. Discrete math and AI and machine learning rely heavily on logic, algorithms, and graph theory. All constants from discrete math. Example: a robot navigating a maze uses graph theory to determine the shortest path. Inductive logic helps AI make decisions based on previous this data. Here's a fun fact for discrete math and how this gentleman here was able to use computer science and discrete math to crack Nazi codes during World War II, revolutionizing computing and saved millions of lives doing so. The beauty and logic of algorithms, how algorithms shape the world, step-by-step procedures to solve problems, sorting and listing numbers, but also quick sorts help organize large databases. And in real life, Google Shorts algorithms uses complex discrete math to rank the most relevant searches results based on your query. A lot of these tags and filters and stuff like that are connections, and these connections help you get the most accurate answer to your question that you're looking for. A lot of this stuff is underlying mathematical problems that allows these programs to display the most accurate information to what you're looking for. The binary algebra and logic gates. In conclusion, discrete structures and the foundation of computing, AI, cryptography, and much more. Real-world applications include graph theory, probability, database designs, and algorithm. Discrete math help us solve complex problems efficiently, logically in both everyday life and technology. And these are our cited sources. Thank you so much.